following initial value problem models the payoff of a loan. Solve the initial value problem for t greater than or equal to 0, graph the solution, and determine the first month in which the loan balance is 0. Round down to the nearest integer. Okay, so for this you're going to be given, more than likely going to be given a formula that says if you have an initial value problem of the form y prime of t is equal to ky plus b, then the solution to that initial value problem is this: y of t is equal to c e to the kt power minus b over k. Okay, so for this particular problem, this is of that form, so the b prime of t is the same as y prime of t. Our y is going to be this 0.002. The y is equal to, or the k is equal to that. The y is equal to the b, so k is equal to the number, y is equal to the b, and then this little b is equal to negative 600. Okay, so we can write that down, and let's just say that k is equal to 0.002, y is equal to b, and little b is equal to negative 600. Okay, given that, we can say that b of t is equal to c. Now c is going to be your constant. We'll have to figure that out ourselves. E to the kt, so kt would be 0.002t, and then it says minus b over k. So minus, it's already negative, so we'll say plus 600 over the k, which is 0.002. Okay, if you put this in the calculator and solve that out, that's going to be 300,000. Okay, so you can say, write that again. Okay, so now we have our solution, but we still have a constant that's floating around, so we need to figure out that constant, which means we need to plug in our initial condition. 0 in for t equals 250,000. So 250,000 equals c e to the 0.002 times 0 plus 300,000. Okay, so if we move that over, the 300,000, that becomes negative 50,000. This, since it's to the 0 power, the e goes and turns into a 1, so it'd be c times 1. So you end up getting negative 50,000 equals c, or c times 1. Okay, so now we can put that in place of c right here, and that is our solution. So negative 50,000 e to the 0.002t plus 300,000. Okay, so that is our solution to this, but it also asked us to graph the solution and determine which month the loan balance is 0. Okay, so if you want to graph this solution, they may or may not give you a window on this problem, like whoever assigns this. So for this particular problem, here is what I chose as my window. Okay, 0 to 920 on the x, and 0 to 260,000 on the y. It's going to go pretty high up there on the y. It's going to go up to 300,000. Well, it could go up to 300,000. So remember, this is an upside down exponential, so it's going to kind of look like this. Okay, and I went ahead and typed it in the calculator. There it is. You can pause if you need to look at that. And then there's the graph. Okay. Now, we have two different ways of going about finding where this is equal to 0, because it did say find when the loan balance is 0. We can set it equal to 0 and solve, which is relatively easy. Or we could put it in the calculator and graphically find the solution. So if you graphically find the solution, 0 in y2, and then second calc and go down to intersect and hit enter 3 times. Okay, so you get x, in our case t, is equal to 895.87. It did say round down. So according to the calculator, t is equal to 895, and that's the first month. It's not quite the first month, but it did say to round down, so it's the first month, according to this problem, that the balance is going to be 0. Now, by hand, quickly, because it's pretty easy, 0 is equal to negative 50,000 e to the 0.002t plus 300,000. Okay, I'm going to subtract the 300,000 and then divide the negative 50,000. So I get negative 300,000 over negative 50,000, which is 6, equals e to the 0.002t. Okay, that is 6. Okay, then I take the ln of both sides, so I can get rid of the e. So ln of 6 is equal to, when I take the ln of the e, it goes away, but the exponent stays, so 0.002t, and I divide this over here, 0.002, and that would be my exact solution if I put that in the calculator to confirm it's the same solution I got with the graphing calculator. ln of 6 divided by 0.002, we get the same answer. Okay, so either way, according to this problem, 895 months before you have a balance of 0. Now, since it was a decimal, technically, when you plug in an 895 into this function, you won't get a 0 as an answer, but you get almost 0. It occurs between the 895th and the 896th month, but they did say round down. So our answer to this problem is 895.